So I asked the students to arrange these items from what feels the cold, what I say, what's coldest to the warmest. And they usually end up with something like this. And then I kind of have them practice it. A few times say, oh no, you got something not quite right. Just kind of fun to do that with them. But then when we introduce it, we say, now actually, yeah, this feels the coldest, but actually all of these are the same temperature because they're all at room temperature in here. It's just that they have different specific heats. This one here hardly absorbs any energy from me at all, so it doesn't feel cold at all. Whereas we move this way, the metal absorbs so much heat from me that right away I feel it as cool. So this is a really nice little activity to introduce the idea of specific heat. And then you talk about the park bench. What's safer to sit on a hot summer day, a metal park bench or a wood park bench? Well, they already know the metal one would probably burn them. So great little activity for introducing specific heat when we're doing our thermodynamics equations. One of the things we do to help introduce the idea of the system and the surroundings in our thermodynamics unit in chemistry is, well, okay, we give the definition of the system is the thing that's the area of focus of study. The surroundings is everything else. And then we give them these definitions. Exothermic means that the system is losing heat. And then we say that an endothermic reaction is that the system is gaining heat, or in this case, energy. So what we've got here, we've got this mousetrap, and I have this, we label this is the system, so that's what we're defining as the system. Let me see if I can set this down so we can see, whoops, what we're doing here. So then what I do is I have the students learn to put these mouse traps together, and that's usually kind of fun because it's kind of a scary process for them. Let me adjust that a bit. So, and I just have them make sure they always have the tail of the mouse trap out like this. It's best if they pull in the middle part of this to open it up, because these mouse traps are fairly frail and really they don't survive students too well. So, okay, and we get this over. And I like these, for this activity, I like these mouse traps. Now I lift up the food holder, gently lift my thumb, and now I can feel that the catch spring here, the pin is in place, so I can move my thumb safely. Now we've got the system set up. We have added energy into this system, which means by definition, this is an endothermic reaction, because interaction, I guess I should say, because we've added energy into it. Then when we release it, okay, then it's an exothermic reaction because it releases some energy. Now, when you have the kids do it, if they want to sit there and just make sure that when they go to snap it, that they're putting their full palm over here, because then it's not quite as hard. Anyway, and we'll show you some students working with those. So that's a really fun intro to thermodynamics interactions of exothermic and endothermic reactions.
We've endothermically loaded the mouse traps, and now we're going to exothermically release the tension. No! Hold on. Crap.
You're being recorded, so use... Wow! There we go. Yeah! Woo! Okay. That's how you put the fun in thermodynamics. We have all endothermically set our mousetraps, the system. We put a ping pong ball for launching. So here we go. 3, 2, 1, fire! All right. There's an exothermic reaction if we've ever seen one.